Hello everyone. In this video, we're going to be solving a cubic equation. We have x cubed minus x plus 2 quantity squared equals 76. And we're going to be solving for x values. And I'll be presenting two methods. Let's go ahead and start with the first one. So for my first method, I'll do the obvious. If you were given a cubic equation, what would you do? You would just try to solve it, right? With the cubic formula, try to factor it, so on and so forth. So let's go ahead and expand what's inside the parentheses. That is x squared plus 4x plus 4. We're going to subtract it from x cubed. So it's going to give us x cubed minus x squared minus 4x minus 4 equals 76. And then you can actually go ahead and subtract 76 from both sides. And that'll give you the full cubic, right? Now take a look at this. Do you think you can factor this easily? One of the ways we use to factor these kinds of expressions is factoring by grouping. But do you think this will allow factoring by grouping? You can check these two terms and these two terms. Unfortunately, we're not going to find the common factor here. This one will give me x squared times x minus 1, and this one is going to give me negative 4 times x plus 20, but unfortunately, these two have nothing in common. So, factoring by grouping does not work. Even if you try to do it differently, it's still not going to work, and worst of all, this is going to give you a sum of two squares. So, what are we going to do? We can try to solve this by using the cubic formula. How does the cubic formula work? Well, a lot of people try to own the formula, right? You know, the Italian guys, there's a huge dispute. But anyways, I'm not going to get into that because I just want to show you how that works. So here's how the cubic formula works. We have, let me rewrite this equation like a kind of like a cleaner copy. So we have this equation now. Our goal is going to be to get rid of x squared. Of course, we're going to use a variable substitution. Let's replace x with something like y plus something. And the reason why we use a plus sign is because when this is a minus sign, you use a plus sign. You get the idea? And then you look at the coefficient of x squared, which is 1. Ignore the negative sign because we already taken care of it. And then you divide that number by the degree of this polynomial, which is 3. So you're going to be adding 1/3. That's how it works. Does that make sense? I hope it does. Now you're going to go ahead and substitute that. Replace x with y plus 1/3. You're going to raise it to the third power. And then minus the same thing squared. So you're going to change the variable. And this allows you to get rid of y squared because your variable is different now. It's not going to be x squared anymore. And you will get rid of y squared. So you'll have a depressed cubic. And you should be able to solve it. Okay, I'll show you how to do that. Let's go on and expand everything. I usually do this, a cubed, b cubed. And then plus 3ab, which is y, multiplied by a plus b. That's the formula, but you can use the binomial theorem directly if you want. This should give you y squared minus 2/3 y minus 1/9. Everything is a negative because we're distributing, so everything is negated. This one is minus 4y minus 4/3 minus 80. Of course, the whole thing is equal to 0 at the very end, right? But let's go ahead and distribute this and see what happens. Y cubed plus 1 over 27 plus y squared plus 1 over 3y minus y squared minus 2 over 3y and then minus 4y. And I can kind of put these together. First of all, these two fractions, that's going to give me negative 12, negative 1, negative 13/9. And then 80 can be written as negative 200 on, actually, that's not true. I got to multiply by 9, so it's going to be 720 over 9. That's going to be negative 733 over 9, and that's equal to 0. That's such an ugly constant at the end, but don't worry too much about it because I'm going to show you the method, and the rest is yours, okay? Now, I've noticed that here we can cancel out the y squared. That was the whole purpose. This also shows that you use the right substitution. If not, go back and change it. Make sure y squared cancels out. And by the way, where this comes from is if you are given a cubic equation like this, right? Let's just say, let's assume that a is 1, so that this is monic. You can basically replace x with something like y plus h, plug it in, and then make sure to make the coefficient of y squared 0. That's how you find the h value. But let me tell you, h from here is going to be negative b over 3 all the time. Okay? But you can test it out, definitely. It's a good exercise. Now, Let's go ahead and put these together. These two will give me negative 1/3, and then I have to consider the negative 4y, so negative 1/3 minus 4, that's like 12/3, negative 13/3. Okay, some weird numbers coming up, negative 13/3 of y, and then I kind of need to take care of the constant, but there's another constant here which I need to take care of. So what we can do is we can actually multiply this by 3. That's going to be 2199 divided by 27, and then subtract. That's going to be a negative sign, but we can keep that number on the right-hand side so that it becomes positive 2198 over 27. I don't know if they have a common factor, if there's a way to factor, simplify this. You can test it out, but here's what I'm going to show you. If you expand a plus b quantity cubed and from it subtract the two terms in the middle from the binomial theorem, you end up with the first and the last terms, which is a cubed plus b cubed, which is the sum of two cubes. And this is the whole idea behind the cubic formula. If you set it equal to y, you basically get y cubed minus 3aby equals a cubed plus b cubed. And then what happens is you compare this equation to that equation. Obviously, you know that one of the roots of this equation is going to be a plus b. Y equals a plus b satisfies this equation. So if you can solve it by finding the values of a and b, of course, by setting the coefficients equal to each other, from here you get ab is equal to 13 over 9, and a cubed plus b cubed is equal to that infamous number, which is 2198 divided by 27. And guess what? You can cube both sides, plug it in, or substitute, whatever you do. This doesn't give you a cubic system or cubic equation. This actually gives you a quadratic equation. That's how you reduce the power so that you can basically solve it. But this turns into a quadratic equation. You find the roots. The roots are a and b, but since obviously a cubed and b cubed, but you're going to set a cubed equal to c, and then from here you're going to find the c values, take the cube roots, add those two, okay? So in other words, something like this, one of the roots is a, the other root is b, let's say. This is going to give you the y value because y is equal to those two. Actually, never mind. You're going to find the roots, take the cube roots, you're going to add them, and that should, yeah, exactly give you the y value. And then you can kind of go from there. But as you can see, this is super duper painful. That's why I have what is called the second method, okay? The second method rocks, but again, it's up to you to decide. Let's see. Now, what was the original problem? It was x cubed minus the quantity x plus 2 squared equals 76. I don't know if you noticed, but these types of problems appear on math competitions. Particularly, I think, in Russia, I've seen quite a few of these because I have a lot of books in Russian, even though I don't speak it. I kind of understand some of the words that are math words, and if there are equations, obviously, you know what they are, right? So here's the idea. On the left-hand side, we have a difference of, I'd like to say 2 cubes or 2 squares, but that's not the case. We have the difference of a cube and a square. Make sense? So if only I could write 76 as such. So can I write 76 as the difference of a cube and a square? And the answer is yes. And the way to do that is 125 minus 49. How do I know this? Because I made up this problem, or I found it somewhere. Actually, this is, I think, like a homemade problem, so I could probably get credit for this. No big deal, because these problems appear all the time, and you can make your own too by looking at this type of thing. So pick an equation like this, and then set it equal to that. But of course, something's got to work at the end, which I'll show you. Okay? So far, so good. Now, let me go ahead and get rid of this number in the middle. We don't want middlemen, right? So now, we're going to go ahead and do a little bit of mathemagic here, or hocus pocus, okay? Now, how do you do that? You bring the cube over to the left, so it becomes like difference of 2 cubes. That's what we want to have. And then bring the square on the right-hand side so that you get a difference of 2 squares. So how is that going to help you, right? You're still probably thinking, hey, wait a minute. Difference of 2 cubes and difference of 2 squares, they don't agree. Well, they kind of do, because if you factor, you kind of write this as x minus 5, right? And then x squared plus 5x plus 25. And then on the right-hand side, this is a difference of 2 squares. This is 7 squared. Remember that? And This is one of the most important formulas. It's x plus 2 plus 7 and x plus 2 minus 7. And guess what? X plus 2 minus 7 is x minus 5. Bingo, you got a common factor. Great, right? So we can go ahead and actually, and this is x plus 9 obviously, so that is factored as a quadratic. Now let's go ahead and put everything on the same side so we can factor by grouping. Let's go ahead and bring this guy over here, x plus 9 and x plus 5, and set the whole thing equal to 0. Awesome. Now we know that x minus 5 is a common factor, so let's go ahead and pull it out. And then the rest comes from here and here, x squared, and just subtract them. Plus 4x, 25 minus 9 is going to be positive 16 equals 0. And guess what? From here, you get x equals 5 as the only real solution. Why? Because this gives you non-real complex solutions. And if you're wondering what complex solutions are going to look like, you can solve it with the quadratic formula. Let's do it. Negative b, you can also complete the square, by the way. Negative b plus minus the square root of b squared minus 4ac, which is 64. That's going to be negative 48, square root of 48i. What is I? I is the square root of negative 1. And by the way, if you want to learn more about I, go ahead and check out my other channel that focuses on complex numbers. It's called A plus BI, just like how you write a complex number in standard form, right? Okay, hopefully you remember that. But let's go ahead and simplify this further. 48 can be written as 16 times 3, so the square root of 16 is 4. It's just going to be negative 4 plus minus 4 root 3i divided by 2, and you can definitely divide everything by 2. That'll give you negative 2 plus minus root 3i. And when you plug in those numbers, you're going to realize they satisfy the original problem, okay? Notice that with the Cardano's or Tartaglia's or Ferrero's, whoever formula you call it, with the cubic formula, hopefully you should be able to get x equals 5, but I don't know. Sometimes you don't. Some irreducible case, irreducibilis, something like that. I can't remember the Latin name for it, but you get the idea. So this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care, and bye-bye.